Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, I want to discuss about the question bank of surface treatments. So already we have seen definition and terminology and some short answer type questions also we have discussed in previous sessions. So in this session, the questions related to the long answer questions related to this wear and surface treatments. So today's topic is the wear and surface treatments. So in this, describe briefly about surface treatments. So in examination they will ask like this: surface treatments are processes applied to the surface of a material to improve its properties. To enhance the property, you have to apply the treatment, surface treatment, such as hardness, wear resistance, corrosion corrosion resistance, and aesthetics. These treatments can be physical or chemical or mechanical in nature. Physical treatment is there and a chemical treatment and mechanical treatment. So all these treatments gives enhancement of properties of materials. So one is the coating. In this coating, electroplating. It is a one treatment process. Deposition of metal layer onto a surface using an electric current. Common metals used include chromium, nickel, and zinc. Next, anodizing. An electrochemical process that forms a protective oxide layer on the surface of metals, primarily aluminum. The powder coating method. Application of a dry powder that is cured under heat to form a hard protective layer. Next, physical vapor deposition, PVD. A vacuum deposition method to produce thin films and coatings. Examples include titanium nitride and chromium nitride coatings. These are coating methods: the electroplating, anodizing, powder coating, and PVD physical vapor deposition. So one more is heat treatment. The heat treatment, one is the carburizing process, nitriding process, and induction hardening process. So due to this carburizing process, they increasing the surface hardness. So increasing means adding carbon to the surface layer of steel by heating it in the presence of a carbon. Nitriding, introducing nitrogen into the surface of steel to form hard nitrates, enhancing wear resistance. So induction hardening, heating the surface of a part using electromagnetic induction followed by rapid cooling to increase hardness. The mechanical treatment, short peening, and laser surface treatment. Bombarding the surface with small spherical media, that is short, to create compressive stresses, improving fatigue resistance. So already you know. So what is this fatigue resistance? We have discussed in previous sessions. Whenever the component or material is subjected to cyclic stresses or cyclic loads, the small cracks will be possible after a certain number of cycles. So after certain number of cycles, what will happen? The crack initiation will be formed. Due to this crack growth, the material will be failure. This type of phenomenon known as fatigue phenomenon. So, by using this short peening treatment, you can improve the fatigue resistance. So, next one is laser surface treatment. Using a laser beam to modify the surface properties such as hardening or creating patterns. So, by using this laser beam, you can modify the surface properties. What are the properties? Surface hardening property, fatigue property, corrosion resistance property. So, all these you can modify by using this laser surface treatment. Next, in chemical treatment, passivation. So, treating metals like stainless steel with a mild oxidant to form a protective oxide layer, enhancing corrosion resistance. Phosphating. Applying a phosphate coating to steel to provide corrosion resistance and improve paint adhesion. The phosphating treatment is to to improve the paint adhesion. Hitching. Using chemicals to selectively remove materials from the surface, often used to cleaning or creating patterns. Hitching means is using chemicals to remove the material from the surface. Whenever you want to remove the coated material, you can use this etching treatment. It's also used for cleaning or creating patterns. Next, thermal spraying. So in thermal spraying, one is plasma spraying, another one is high velocity oxygen fuel (HVO). The melting materials in a plasma jet and spraying them onto a surface to form a coating. The common materials include ceramics and materials. The HVOF, that is high velocity oxygen fuel, using high velocity gases to spray molten or semi molten materials onto a surface, resulting in a dense and strong coating. Next, ion implementation. So, bombarding the surface with high energy ions to modify its properties, such as hardness and wear, already we have seen in a previous slide. Electrolysis plating. In chemical deposition of a metal layer, commonly nickel, onto a surface without using an electric current, resulting in a uniform coating. Electrolysis plating means chemical deposition of a metal layer so onto a surface. So in this, no need of electric current. So resulting in uniform coating. So another process also there, that is electrochemical plating. So in that case, the electricity is required, electric current is required. With the help of electricity, the deposition of material will be occur. Chemical vapor deposition (CVD), a process where gases reactants form a solid material on the substrate surface through chemical reactions, often used for coatings like diamond or silicon carbide. So next one is describe briefly about international standards in wear measurement. So what are the standards available for wear measurements? You have to describe briefly. The international standards for wear measurements provide guidelines to procedures to ensure consistent consistent and reliable testing of materials for wear resistance. These standards are developed by organizations such as ASTM International, ISO International Organization for Standardization, and DIN Standardization. So one is ASTM standards, ASMG 99. The standard describes the test method for weight testing with a pin on disc operators. We have studied in previous slides the pin on disc test operators. It specifies procedures for measuring the wear of materials under sliding conditions. ASTM G65. This standard outlines the dry sand or rubber wheel operators method for measuring the abrasion resistance of metallic materials. It is often used to evaluate the abrasive wear resistance. ASTM G99, ASTM G65. Next, ASTM G133. This standard covers the linearly reciprocating ball and flat sliding wear test. It provides guidelines for measuring wear under reciprocating motion. Next, ASTM D3702. This standard specifies test methods for evaluating the wear properties of polymer materials using a thrust washer testing machine. All these core standards comes under ASTM. ASTM G99, ASTM G65, ASTM G133, and ASTM D3702. So other standards are ISO standards. So ISO 20808, the standards specify the test method for the determination of the wear resistance of ceramics using a reciprocating sliding method. So you can measure the determine the wear resistance of ceramics using this reciprocating sliding method. The user standard is ISO 20808. The ISO 71482, the standard provides methods for testing the tribological properties of plain bearings and focusing and dry and lubricated conditions. Next, ISO 8251. The standard covers the methods for evaluating the wear resistance of coatings by the Tabor abrasor method, and which involves rotating abrasive wheels against the coating. Next, DIN standards. DIN 50320. The standard describes the pin on disc wear testing method similar to ASTM G99, focusing on the measurement of friction and wear. The DIN 51834, the standard outlines the procedures for testing lubricating greases using a 4-ball tester to evaluate wear and extreme pressure properties. In DIN 50320, this describes the pin on disc wear testing method. We have studied in previous sessions. This method similar to ASTM G99. So only this standard focusing on friction and wear. So DIN 51834 focusing on testing lubricating greases using a 4-ball tester to evaluate wear and extreme pressure properties. The other standards are ISO 12947. The standard covers the Martinelli vibration testing method commonly used for textiles to determine their resistance to wear. So by the standard covers the Martinelli abrasion testing method. So this one is commonly used for textiles to determine their resistance to wear. So next ISO 17025, while not specific to wear testing, this standard specifies general requirements for the competence of testing and calibration laboratories, ensuring reliable and accurate measurement results. So these are the other standards. So next question is, explain briefly about surface fatigue wear and how it is controlled. So we have discussed in a previous session the fatigue about fatigue. So this type of fatigue wear occurs when repeated cyclic loading and unloading cause the surface and subsurface layers of a material to crack and eventually wear away. So whenever the component are subjected to cyclic loading or repeated loading, so due to this, the crack formation will be occur. So this phenomenon is known as fatigue. So eventually, this type of wear is common in a component subjected to rolling or sliding, such as bearings, gears, and camshafts. In mechanical engineering, the engine having camshafts and piston and cylinder and bearings. In bearings, the rolling and sliding contact bearings are there, and the gears. So the fatigue wear occurred in this surface in these mechanical components whenever two components are in relative motion. So this type of wear is known as surface fatigue wear. How it is controlled? So surface fatigue wear mechanism. Surface fatigue wear initiates when cyclic stress exceeds the material's endurance limit, leading to microcracks. These cracks propagate with the continued loading cycles, eventually leading to material removal. The surface fatigue wear is characterized by fitting, spalling, and flaking. The main factors influence surface fatigue wear include contact stress, material properties, surface roughness, lubrication, and environmental conditions. These are the key factors. So the surface fatigue wear mechanism we have learned, and then key factors also we have seen. Next, controlling the surface fatigue wear. So how to control this fatigue wear? So one is selection, the material selection. You should know about the strength of material and the hardness of the material. So one is high strength materials. Using materials with a high fatigue strength and toughness can reduce the successibility of two surface fatigue wear. Yes, sir. Here you can improve the successibility and you can reduce the susceptible ability to surface fatigue wear. The case hardening techniques such as carburizing, nitriding, induction hardening can create a hard surface layer while maintaining a tough core, enhancing resistance to fatigue wear. So that the designer, while selecting a material, these 2 points should carefully remember the high strength materials and the case hardening. The surface treatments, coatings, and the surface smoothing. So coating means applying wear resistant coatings such as PVD, physical vapor deposition, CVD, chemical vapor deposition, or thermal spray coatings can protect the substrate from fatigue. And then surface smoothing, polishing and grinding to reduce surface roughness and eliminate stress concentrations can help in preventing crack initiation. So eliminate concentrators help in preventing the crack initiation. Suppose the uniform bar is there whenever this is subjected to tensile load. So there is the uniform distribution of stress lines. Whenever the component having some wall at its center, the stress distribution lines are not in uniform. The stress distribution lines are distributed like this. So wherever at this wall, the stress distribution lines are bent like this, not in uniform, their stress concentration will be high. So due to this stress concentration, the component will fail at this center. So to avoid this preventing crack initiation, the surface smoothing operation is important, treatment is important. Thus mainly the stress concentration, the poor concentration will be occurred due to the poor surface finish. Okay? So while designing the component, you should remember these points. Design modifications, contact geometry and surface profiles. So optimizing the geometry of contact surfaces to distribute loads more evenly and reduce peak stresses. Designing components with favorable surface profiles to minimize stress concentrations and avoid sharp corners. It's already seen in previous slide. Next, lubrication. The quality lubricants, hydrodynamic lubrication, and load management. So using high quality lubricants with appropriate additives to reduce the friction and wear. Similar hydrodynamic lubrication. Ensuring adequate lubrication to maintain a fluid film between contact surfaces, preventing direct metal to metal contact. The load management, load reduction, avoiding overloading can decrease the cycle stresses experienced by the material. Similarly, stress relieving. Applying techniques like short meaning, already we have seen in the previous slides, introduce compressive residual stresses, which contract tensile stress and delay crack initiation. So maintenance and monitoring. So regular inspection. Early signs of surface fatigue wear and take corrective actions to improve the reduce the wear and friction. Condition monitoring. Implementing condition monitoring systems to track the health of critical components and predict wear before catastrophic failure occurs. So these are the references I have taken for this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.